So let's check how we can solve reorder list task of type medium. So you are given the heads of a single linked list, and we need to reorder the list in that way that L0 points to L1, which is actually the last element from the original linked list. Then L1 points to Ln minus 1 and so on. So you can analyze it a little bit better, but I hope this idea is clear. So below we have an example where we initially have a linked list in that form that 1 points to 2, 2 to 3, 3 to 4, and so on. And we need to have like outputs of the results should be 1, 4, the last element, 2, 3, and so on. I hope it's clear. So now let's check the algorithm. So visualization of the algorithm which we need to implement. So let's imagine that we have this linked list with values 1, 2, 3, 4, and 5. And what should we do? So if you haven't checked the previous 3 exercises on the channel, I really recommend to do that, because it's this task is a combination between these 3 exercises. So the first thing which we need to do here is to declare 2 pointers, slow and fast, because we want to find the middle of our linked list and somehow to separate our linked list in 2 parts. So let's check how it works. So we initialize slow pointer, then fast pointer. Initially they points to the same element of a linked list, the head of a linked list, and then we start the iteration. So the slow will move to 1 step, but fast to 2 steps. And doing so, when we will finish to iterate, slow will point to the middle of this linked list. That's it. Why we want to do this? Because we want to separate, how I already mentioned, our list into parts, and the second part to reverse. And you'll see why I want to do this. So we found the middle of a linked list, and now I create the variable. We need to create the variable, the pointer current node, which will point to, let's say, the first element of our separated part of our linked list. So how it will look something like that. So we will have kinda 2 linked list, 1, 2, 3, and the second one will be 4 and 5, and this one we will need to revert. So we are doing so, we revert this list. So we will have something like that. Yeah, so that's the idea here. And last thing which we need to do is, first of all, we will create 2 variables, 2 pointers, first and second. First pointer will point to the head of the original linked list, let's say, to the first part, and the second will point to the head of the second part of our linked list. So the first points to the first element from the first part of the linked list, and second to the second one. You can see it here. And then because we will change these addresses to the next elements, yeah, and here also we need somewhere to store this part and this also, yeah, because we will need to make the same logic and the same iteration for the next elements. We need to save them somewhere, and because of that we create 2 pointers again, temp1 and temp2. In the temp1 we will store next element for first part of a linked list, and in temp2 we will store next element for the second part of a linked list. And then we can change these addresses and not to be afraid that we will lose this data. So the first thing, we change the address to the next element for the first linked list, and it will point to the first element from the second part of a linked list. And also we will need to change the address for this element, which will point what we are storing in the temp1, which is the next element of a first element from the first part of a linked list, which was set initially. So you can see how does it work. So in the end we will have something like that. So we will have 1, 5, 2, 3. Yeah, so it's match our condition, and we just will repeat these steps until we will have this result. I feel, and I would not be surprised if you don't really understand fully how this algorithm is working, because we have a lot of variables here. It could be confusing. So let's go and try to implement it in the code, and maybe it will be a little bit clear for you. So let's go. So I already mentioned the last three exercise which we have solved in the previous videos. Will help you better to understand this task, because this task is a combination of these three. So I really suggest you to check them step by step. But let's continue with this one, and let's check how we can solve this one, and to use already gained knowledge. So first of all, let's create the signature of our method, public static void, let's call it reorder list. Okay, and like argument, we will have here the first node, the hat of the linked list. So node hat. Okay, perfect. Okay, let's first of all check if this hat is not equal to null. So if hat is equal to null, or if hat next node is equal to null, then in that case we can return and finish our method. Okay, now let's create two pointers, slow and fast. Why we need them? Because I want to find the middle of linked list. Here probably we need to use not or but and or what does it say? Pointer exception. It will produce null pointer exception. Okay, I will think a little bit later about this. So again, why we need slow and fast pointers? Because I want to find the middle of a linked list and to separate my linked list into parts. And the second part I will revert, and then it will be easier to solve this exercise. So let's create the first pointer, not slow. It will initially point to the first node, and the node fast, which is equal to head also. Now let's continue to iterate through our linked list. So we will iterate until that moment then fast is not equal to null, because if fast is equal to null, it means that we don't have to iterate through anything. And until I think we can remove this condition, and until the moment fast dot next node is not equal to null. Okay, perfect. So there's this is the condition. And in each iteration, we will move our slow pointer to one step. We'll move it to one step, and the fast pointer we will move to two steps. Fast, next node, next node. Again, why we need this condition? Because if this will be equal to null, this thing will return null pointer exception. Okay, perfect. This is the first step. The first step where we need to find the middle of a linked list. Now I want to revert my second part of a linked list. And first of all, what I want to do is to declare a pointer current node, which will point to slow.next node. So it will be the next node after the middle one. And the slow next node will be equal to null, because I want to separate my linked list into parts. And also let's declare previous pointer, which initially will be equal to null. And now let's revert our second part of a linked list. So let's declare while. While, and the condition will be that we will iterate until the moment current node is not equal to null. Okay, perfect. Now here let's create a temporary variable temp node, where we will store the next element after the current one. Yeah, because for the current one we will change the next pointer to the previous value. And if we will not store the next elements for the current node, we will lose them. Yeah, because now the current node will point to something else. So let's store this in the temporary pointer. So let's write here current node, next node. And now let's take our current nodes, next nodes, which will point to the previous node. And now let's change the previous node, which will be in the next iteration, it will be equal to current node. And the current node we will change to the next element after the current node. Actually to the temporary. Yeah, temporary node, what we are storing in the temporary node, but in the temporary node we store the next element after the current node. So temp node. Why we cannot do something like this, current node dot next node? Because you can see that here we already changed the next node to point to another value. And if we will do something like this, it will mean that this thing will point to the previous, but not to the next nodes which was set initially. Yeah, so because of that we write here temp node, and that's it. So we have reverted the second part of our linked list. Nice. And now let's declare two variables which will point to headers for first part of a linked list and for second part of a linked list. So let's write here, first head, let's say, which will be equal to head, and second head, node head, which will point to previous. Why previous but not current node? Because current node in the end will be equal to null, and we will stop to iterate through the second part of a linked list. And when we will stop to do this, so when we will reach the null value, then previous will be equal to the last element of the second linked list. And now let's create a while, because we need to iterate, and the condition will be that we will iterate until the moment second head is not equal to null. Null. Why second head? Because second head always will be the size of the second half of a linked list will be less than the first part, so the first linked list. Yeah, because here, if you remember, I have found the half of a linked list to which slow pointed. But when we started and reverted the second part of a linked list, we started from the next element, not from the element from the middle, but from the element which is next from element in the middle. All right, so that's the condition here. And what we need to do now, so let's create temporary variables for first list and for second list. So let's declare them temp1, which will be equal to head.next node, and node temp2, which will be equal to actually here it's not very correct. Here should be first head, I think. Yeah, first, yes, and here will be second head, next node. Perfect. And now we can change the links, the addresses to the next elements without to be afraid that we will lose some data. So let's do this. So for first head, we'll point next node to the first element from the second list, which is second head, and second head will point to the second element which was initially in the first linked list, which we store in the temp1. Perfect. And now let's move to the next elements. So now first head will be equal to what we store in temp1, and second head will point to what we store in temp2. Okay, perfect. So that's the solution. I hope it was useful for you, and we will see in the next video.